All right, so I got some new code. So I modified the code here a little bit because what I want to do is we want to load the features for the two sets of data. We got our samples for the soldiers and samples for the gameplay. But I want it, but rather than having them, let me just show you. Let me just run this real quick. So let's just run. So and I'm going to pull up the features as the author had it. And he's putting these things in cells, right? So, that's great. You're in MATLAB, but the problem is that that's just a lot of, there's just a lot of data there, right? What's what. So so I wrote some code here, which says make CSV, but I actually didn't put the right table in the CSV thing. I should put it down there. But let's create a table that has all of our samples in one table with all of the labels. And my God, that was kind of painful. And my MATLAB foo is not that strong, but here it is. And so remember I was saying the first 35 are all the means, right? And then the next 35 are I think it's the standard deviation, or it's the median, and then the standard deviation, yada, yada, yada. And then I'm adding another entry at the end, which is the label. So, this saying that for all of this data, looking at all of the different features, this one is a soldier. Likewise, this one's a soldier. But starting down here, these are just gameplay. So they're sounds that don't have gameplay, right? All right, so with that said, we've already know, like, if you just follow on the code, we'll do it. But let's kind of see what happens if we write it to a CSV file and use the tools within MATLAB and their ML stuff. I don't know this a lot, but it's kind of interesting to look at. So the first thing I want to do is I want to pull up that CSV file that we made. And we use this little app, just kind of a cool little app. I think maybe it costs $1 or something, or maybe it was free on the App Store, but it's just a CSV viewer. And we have a header, so when we did this right table down here, it's going to make all of those column headings so we can kind of see what features are important, maybe. That's the goal. And we've got our labels, so that kind of matches what's in the little viewer. All right, so let's go here, and I could do it from a file, and I'm going to try to use that file in some other tools. But here we can just go to Workspace, and he's going to say, oh, I can't, if I do this, everything's going to crap out, and he pulls up this thing. Now, what's interesting is this MATLAB tool that automatically is saying, oh, there's the first guy. For that guy, what are they're saying features, they're saying predictors, and he automatically recognizes that this label is my response. This one, it seems, for whatever reason, this chroma vector number 5 has a lot of nans in it. I went back and I looked at the data, and it did, so maybe there's something wrong with the code there, but that's okay. Cross-validation is for how you're going to, how you're going to make your test, or your validation test. So I'm not going to do that. And this is cross because we don't have a lot of data to make sure that we have everything separate. So I'm going to have to reuse, and sum over. All right, so let's just start this session and train it up. That's a complex tree, so I don't know, I picked one, I guess it picked one by default. But let's look at the different types that we can do. And we know in the code that the guy wrote, he's going to do a nearest neighbor classifier, and he's going to, I think the best value came around 5 or 6 nearest neighbors. So we'll just do like the nearest neighbor, and see how we work. So now we're saying that, and then you click this train button. And by the way, if you remember from that last thing, this is very similar, right? mean energy, mean ZCR. This is what we've selected for our predictors, and he's already got the colors correct. But let's just train it, and he's going to go over it. He's going to come out with an accuracy of 72.7%, or 3/4. So 3/4 of the time he's correct. There's two different, metrics. There's accuracy and something else, and I can't remember. For accuracy and precision, I think, for determining like the characteristics of a result. But anyway, don't get caught up in the terms. You can see here now, instead of looking at data, we're looking at model predictions, and we can see that there are errors, and the errors are in different colors based upon what type of error is it. Is it true positive or true negative? False positive, false negative. All right, so we can pull up the confusion matrix, and what this is saying is this is the true class. So for the 41 samples of gameplay, 33 of them were predicted correctly as gameplay. 8 of them were predicted as a soldier. The soldier itself, you're about 50-50, right? So half the time you're going to predict it as a gameplay, and half the time you're going to predict it. Anywho, whatever. Let's see what else we can do. We'll make a simple tree. Simple tree is, SVMs are quite popular, but let's just try to make this quick and easy. A simple one. Let's train this, and let's see. For model 2, so let's go to the scatter plot first. So maybe we're not counting as many x's on this simple one, and it's not going to. This tree is going to be less susceptible to overfitting, meaning that your model is great for your training data, but it's not so great for just data in general. So with this one, it's funny. Gameplay is correctly identified quite well. The soldier itself, he's much better as well. So you got like 11. So if it is a soldier, 11 of the 14 are predicted correctly. And so there's an ROC curve. I'm not exactly 100% on this. I don't know what this is, but there's a button there if I want to look it up. Yada yada yada. So we'll get back to this simple tree here just for grins. This means there's 4 splits. I would like to know what those 4 features were that were split off, but I don't know enough about this to figure that out. I'm sure there is. I guess we can go back. Maybe. The PCA thing is like saying you're going to take out redundant data, which should come into play here. But let's see. So that's that. I guess that's enough to show here.